All right. So from here, we are asked, find the temperature at which the Celsius and Fahrenheit thermometer have the same reading. Now, here we are still going to use extrapolation method. Okay, so this relationship between Celsius and Fahrenheit. So this time around, we have it this way. So we have degree Celsius and we have degree Fahrenheit. Remember, for degree Celsius, the upper fixed point is 100 and the lower fixed point is 0. So do I know the fundamental interval? No. I can call that place what? Theta. The same thing with this. The upper fixed point is 212 and the lower fixed point is 32. So I can also call here what? Theta. So remember, here is A, B, and C. A1, B1, and C1. So this time around, okay, we have it like this. A minus C over B minus C equals to A1 minus C1 over B1 minus C1. So here, our A is sitting as 100 minus what? 0. All over B is what? Theta. Then minus what? 0. Then equals to A1 is what? 212. Then minus what? 32. Then all over theta. Then minus what? 32. 100 minus 0, we have 100. Then theta minus 0, we have theta. Then equals to 212 minus 32 is 180. Then all over theta minus 32. So what do we do? Cross multiply. So here we have 100 bracket theta minus 32 equals to 180 theta. So what do you do? This to open all the bracket. 100 times theta, we have 100 theta. 100 times minus 32 minus 3200 equals to 180 theta. What do we do here? Collect like terms. So here we have 100 theta. If 180 is crossing over, we have minus 180 theta. Then equals to, once 3200 is crossing over, we have 3200. So 100 minus 180, we have minus 80 theta equals to 3200. To get theta, divide both sides by minus 180. So our theta equals to 3200 divided by minus 180. So from there, our theta is going to give us 3200 minus 180 divided by 180, which gives us minus 40 degree. Okay, it simply means that, therefore, our theta is sitting at minus 40 degrees Celsius or minus 40 degree Fahrenheit. So that is for that. So this is the exam question. So you can copy. A resistance, sorry, a faulty thermometer has its fixed point marked 5 degree and 95 degree. What will be the correct temperature? What will be the correct temperature in degrees Celsius when the thermometer reads when the thermometer reads 59 degree? So here, we are still going to use extrapolation method. Okay, so we are told that a faulty thermometer, okay, a thermometer that is bad is not good. Okay, now probably is not yet calibrated. So a faulty thermometer, the thermometer has an issue. Okay, as its fixed point, my can see is in 5 degree and 95 degree, not even in degrees Celsius. So now we have it like this. So that means we have a 40 thermometer and a true thermometer. So this time around, we were told that it was marked 5 degree and 95 degree. Okay, you know that, take note, your upper fixed point is always bigger than your lower fixed point. So our upper fixed point here is 95 and the lower fixed point is what? Is 5. They were now told that what will be the correct temperature in degrees Celsius. Remember, for degrees Celsius, your upper fixed point is 100 and lower fixed point is what? Is 0. So when the temperature reaches in 39 degree, so here we have what? 59, sorry, 59 degrees. So we are looking for what was there. Remember, this A, B, and C. A1, B1, and C1. So we have it as A minus C, B minus C. A1 minus C1 over B1 minus C1. So our A is sitting as what? 95 minus 5. Then all over 59, then minus 5 equals to A1 is what? 100 minus 0 over theta minus 0. 95 minus 5 is what? 90. Then 59 minus 5 should give us 54. Then equals to 100 over theta. So what do we do from there? We're going to cross multiply. So by cross multiplication, 90 times theta, we have 90 theta. Then equals to 100 times 54. So we have 90 theta equals to 5400. To get theta, we divide both sides by 180. 5400 divided by 90. So our theta is going to give us 5400 divided by 90. We have 60. So our 60 is going to be what? Degree Celsius. So what we have here is what? 60 degrees Celsius. So when the 40 thermometer reaches 59 degree, then the true thermometer reads how many? 60 degree. So you can copy that. The highs and steep points of a certain thermometer are found to be 20 centimeters apart. What temperature is recorded in degree Celsius when the length of the mercury is 5 centimeters above the ice point mark. All right, so look at this. Still similar to the one we did before. So here we are told that the highs and steep point was a lower fixed point and the upper fixed point of a certain thermometer are found to be what? 20 centimeter apart. The distance between them apart, I've told you before, that if you are counting from 0 till you get to what, 20. So this time around, we have it like this in centimeter. Right, the distance that is from 0 to what? To 20. They were now told that the temperature is recorded, what temperature is recorded in degrees Celsius. So remember, for degrees Celsius, here is 100 and here is 0. So we are looking for what is here. Okay, so this time around, they say when the length of the mercury is 5 centimeter above the highest point mass, above the lower point is what? Is 5. So here, what we have here is 5. Okay, remember, here is A, B, and C. A1, B1, and C1. So this time around, so we have it as A minus C, B minus C. A1 minus C1, B1 minus C1. So our A is what? 20 minus 0 over 5 minus 0. So 100 minus 0 over theta minus 0. So 20 minus 0 give us 20 over 5. Then 100 over theta. What do we cross multiply? 20 times theta, we have 20 theta. Then equals to 100 then times 5. So here we have 20 theta equals to 500. To get that, divide both sides by 20. So here we have theta equals to 500 divided by 20. So our theta is going to give us 25 degrees Celsius. So that is for that. So a mercury in glass thermometer read 20 degrees at the ice point and 100 degrees at the steam point. They calculate the Celsius temperature corresponding to 70 degrees on the thermometer. So now you can try this on your own. Okay, so probably this is where we are going to stop for today. Okay, so we are going to have another class by Friday. Yeah, we are going to have another class by Friday, and we also have a class on Saturday, if possible, by God's grace. Okay, so we are going to have another class. Although we might have class tomorrow. Okay, so I have to check when ND2 is going to have there, so I'll know if I will be able to this class tomorrow or not. Okay, so thank you very much for taking our time to be part of this. Ensure, if you have not followed, okay, just click on the subscribe button so that when next I come live, okay, you'll be notified. Okay, you'll be notified. Okay, it might be for ND2, it might be for ND1, it's for your call, then you can decide to join the live stream. Okay, so always ensure you share it to your fellow classmates, okay, so that they can benefit from this and they can be part of it, especially during this holiday period. Okay, so thank you very much for being a part of this class. Now, the thing there is, you can always rewatch the videos. Okay, if you don't understand, you can watch it over and over again. Definitely, you are going to understand. You can see I've solved several questions on a particular topic. Okay, so there's no way you are not going to understand. Okay, probably for the next class for heat energy, okay, we still have questions, okay, in this chapter 1 that we've not yet solved. Okay, we've only solved up to chapter that exercise 9. We have 10, 11, 12, 13, 14, 15, 16. A lot is wrong.